Again, we have a given function or dy over dx, ODE, ordinary differential equation, which is equal to a to the x, 8e to the x minus 3 sine of y. And again, with the same givens, I is equals to 0, h is equals to 0.5, xo is equals to 0, and y sub o is equal to 0.5. The difference here is we will be starting at k1 and k2. In k1, it is equal to function of xo and y sub o. So, it is equal to 8e raised to x, which is 0, minus 3 sine of y. Our y here is 0.5. So, we substitute 0.5 here. Then, the answer for k1 is 6.5617 or 6.5617. And for k2, we have here function of xo plus 1 half h and yo plus 1 half k1h. So, we will simply substitute the values here for function xo plus 1 half h. We have function of 0 plus 1 half times h, which is 0.5. And for yo plus 1 half k1h, again substitute for yo 0.5 plus 1 half k1. Our answer here is 6.5617 times h again, which is 0.5. For the k2, we have here for the final answer f of 0.25 and 2.1404.
Go.
And for this function 0.25, 2.1404, we will simply plug those values in this function 8e raised to x minus 3 sine of y. In 8e raised to 0.25, plug here, minus 3 sine of y, which is 2.1404. Then we will be arriving here at 3.7041. The final step, we will be using this formula for midpoint, yi plus 1, which is equal to y sub 0 plus k2 times h. Then equals 0.5, substituting y of 0, plus 3.7041, substituting the k2 as we solved earlier, times h, which is 0.5. Then the final answer is 2.3521.